So let us try solving this problem. 3000 joules of heat is added to a system and 2500 joules of work is done by the system. So what is the change in internal energy of the system? So for this kind of problem, we have to use this equation. So delta U, which represents the internal energy of the system, equals to Q, which represents the heat energy in or out of the system, minus W, which represents the work performed by the system. So this equation is associated with the first law of thermodynamics, which basically the principle of the conservation of energy. So in thermodynamics, there are two ways in which heat, or two ways in which you can change the internal energy of a system. You can do work on a system, or the system can do work on the surroundings, or heat would flow into or out of the system. So these are principal ways in which to change the internal energy of the system in thermodynamics. So energy has to be conserved, and it can just come from anywhere. Also, first law says that the internal energy of a system has to be equal to the work that is being done in the system, plus or minus the heat that flows in or out of the system, and any other work that is done on the system. We should know that if Q is positive, heat is added to the system. If Q is negative, heat is removed from the system. Work, or W, is positive. It means that work is done by the system, and if work is negative, work is done on the system. So with this basic concept, we should be able to solve this basic problem. So 3000 joules of heat is added to a system, which means Q is positive, and 2500 joules of work is done by the system, so our work is positive. So let us substitute the values to our equation. So delta U equals, so Q is positive 3000 joules, then plus or minus positive 2500 joules of work. So delta U equals to 3000 minus 2500, 500 joules. So let us solve the second problem. 2000 joules of heat is added to a system, and 2500 joules of work is done on the system. What is the change in internal energy of the system? So again, we will be using the first law of thermodynamics equation. So change in internal energy equals Q minus W. So again, Q represents heat and W represents work. Okay, so since heat is added to a system, so we have Q is positive and work is done on, so if it's on the system, work is negative. So let us just substitute the values. So delta U equals, so Q 2000 joules, then minus negative 2500 joules. So negative, negative, positive. So our delta U is equals to 4500 joules. Okay, so let us solve this third problem. 2000 joule of heat leaves the system and 2500 joules of work is done on the system. What is the change in internal energy of the system? So delta U equals to Q minus W. So we know that if Q is removed or leaves the system, Q is negative, and work is done on the system, then since it's on, work is negative. Okay, so just substitute the values. Delta U equals to Q negative 2000 joules minus negative 2500 joules equals to negative 2000 joules positive 2500 joules. So our delta U, or change in internal energy, is 500 joules. So in conclusion, if heat is added to the system, then the internal energy of the system increases. If heat leaves the system, then the internal energy of the system decreases. If the work is done by the system, then the internal energy of the system decreases. If the work is done on the system, then the internal energy of the system increases.